Sure, let us start.
Yes, sir.
Uh, I think last time we have already discussed the concepts of game theory. Uh, in short, I will repeat. I will have a short revision. The last time, whatever we discussed, the theoretical concepts. In our syllabus, they have included the concept that is 2 by 2 zero sum game, pivots and mixed strategy game. What do a pivot strategy, what do a mixed strategy, and how the example is to be solved by using the different methods to be discussed. Say, as I said, in a game, the somebody must win and somebody must lose. Otherwise, we cannot say it is a game. In a game, there is no single party. Always there are two parties, minimum two parties, or more than two. The player, it is called a player. Party means player. A player may be a single person or a group of person at one side, and again to the other side, maybe a single person or a group of person they are playing the games. Right now, this game theory, this comes under the decision theory of scientific techniques of decision science. This method is developed by the J.V. Newman, which is the founder of game theory. And he has given the name of this game theory is the two different strategies are applied. The first strategy is mini-max. That means from minimum we have to find out the maximum, and maximum means from maximum we have to find out a minimum. We'll see with the help of example. So that is why this J.V. Newman is called a father of a game theory. Each player will act as maximize the gain or minimize the loss. There are two opportunities. The player is playing a game to either maximize the profit or otherwise he will play a game how to try to reduce the loss. Right? Now, here one example last time I quoted, there are two companies fighting to increase their market share. Yes, how to increase the market share. So there are two best course of actions. There are two best possible methods. Last time, as we quoted that the prices, prices either we have to reduce the price or we have to same the same, we have to keep the same price, right? So increasing the price, this will not get the solution. That is why the sale, how to increase the sale, either we have to decrease the price or we have to maintain the same price, but we have to adopt the other strategies, say for example, advertising, promotions, right? So it's depend upon the example or a situation. The game theory is helps in determining the best course of action or the strategy for a firm. So while playing a game, the every person it has got a more than one constraint, and which constraint to be adopted. That means there are more multiple states, there are multiple strategies are there, and which is the best possible strategy to be adopted to find the solution of the game means the maximize the profit or minimize the loss. The definition of game theory is it is a technique of operation research which deals with making a decision. As I said, there are two or more intelligent and rational opponents, means players, are involved under conditions of conflict and competition. Because if two or more persons playing a game and they came together, then the conflict is going to be created, competition is going to be created, and from that competition, we have to apply the different strategy and take the decision. In a game theory, the last time we already discussed, there are some certain characteristics or they are also called terminologies are used in a game theory. The player, each participant is called a player, and minimum there are two players. That is why in the game theory, there may be a 2 by 2 player, maybe a 2 by n player, or maybe n by 2 player, or maybe n by n player. Doesn't matter, right? Say, if you see the cricket match, there are many players, many teams are there. Team means it is a player, one side, right? So multiple combinations of matches are there. Say, it means that in a game there are maybe a one or multiple players are there, and they are playing the game by adopting their different strategies, right? Which strategy is to be selected, that is pay. Strategy or change of strategy, that is what I said, strategies. There are multiple strategies. Multiple means it may be a finite number of strategies or infinite number of strategies. Finite number of strategies, it is decided. Okay, n number of different strategies. Suppose there are three strategies, four strategies. So out of these three or four strategies, only the strategy to be adopted while finding the solution. Which are the available to players? Yes, these are the strategies available to the players. These are the options available to the players. These are the actions available to the player. These are the states available to the player in order to, same example I quoted, to increase the market share or maintain. The example is, in order to market shares, as I quoted here, either we have to reduce the price or we have to maintain the same price, right? Now there are two types of strategy. In a game theory, there are two types of strategy. The first is the pure strategy and another one is the mixed strategy. With the help of example, we'll discuss. What do I mean? Pure strategy? The pure strategy means the decision of the player to always select a particular strategy. In another words, I will tell you, if there is a saddle point, then it is called a pure strategy. If there is no saddle point, it is called a mixed strategy. If there is a saddle point, the first condition is fulfilled. If there is no saddle point, this mixed strategy condition is going to be fulfilled. Right? So numerically we'll discuss so that we'll understand. In a mixed strategy, distance of the players, multiple players, to choose one or more strategy with a fixed probabilities. The fixed probability is given, and this is this has got an advantage because the it will keep on the guessing to the next player or opponent player. Number of persons, the game, as I said, n person game, 2 by 2 person game, or n by n person games. Number of activities, there are finite or infinite activity. Yes, there are finite or number of infinite activities as well as this strategies may be finite or infinite. Number of alternative choices available to each person in a particular activity may also be finite or infinite. As I said, finite game has the finite number of activities, otherwise it is called an infinite game. Right? So in case of game, if you have two attempts, that is called an finite. If there is no limitation of attempts in a game, then it is called an infinite game. Are you getting or not? If there is a restriction of attempting the games, if there is a restriction to the players, then it is called an finite number of game. If there is no restrictions, you can appear n number of times. It is called an infinite game. Okay, the payoff. This is an outcome of playing game. It's known as a payoff, and it is represented with the help of a matrix. And the payoff is represented the net gain or the net loss, right? The net gain for the for each combination of strategy adopted by them. Either a net loss, that means how much loss is going to be reduced. Payoff matrix. It is a table showing the payoff for the different strategy of the game. So what are the different strategy and their historical data is represented in the table, and this is the in the form of a problem. As I said last time, the player P is minimizing player, player E is maximizing the player. That means the aim of a player is to maximize the profit, the aim of the player B is minimize the loss. Right? Now the strategies, as I said, there may be a more than two strategies. There were one strategy. If there is only one strategy, no need to apply the game concepts. So always there are more than one strategy. So strategies A1 and A2 for player A. There are two strategies are there. For player B, there are B1, B2 and B3. There are three strategies. So now the player has got an option to select either a strategy A1 or a strategy A2. Similarly, the player B has got an option to minimize the loss That is, there are three strategies: B1, B2, B3. So player B may opt B1, B2, or B3. The optimum strategy. That means finally the which game who is going to winner, that is called an optimal strategy. So out of this strategy A1 and A2, A has to select either A1 or A2. Which one is to be selected, that is an optimal strategy. Similarly, B has to select either B1, B2, B3. So whichever is selected, that is called an optimal strategy, and this optimal strategy is to be selected depending upon the game concept, that is value of the game. So we have to calculate, we have to work out the expected payoff of the play when all players follow their optimal strategy. The game is called fair if the value of the game is zero. Keep in mind, as I said last time in MCQ questions, the game is called fair in case of the game value is zero, and unfair if it is non-zero. That means the final calculated value is zero, then it is fair game. Final calculated value is either less or more than the zero, either plus or minus, then it is called an unfair game. Type of games, right? Game represents the competitive situation which has more than one player. See, type of games, as I said, the two-person game, right? That is called 2 by 2 game. Say n multiple person game, that is called n person game. Maybe n by 2, 2 by n, or n by n game. Next concept is, right? Say types of game. What were two person game? There are two competitors. Multiple means there are more than two competitors are there. Say n. Hmm? Concept. Try to understand concept. Are you getting or not? Are you with me? Are you
Yes,
getting
sir.
me? Hmm?
Yes, sir.
Try to understand the concept because the complete example is not expected in the examination, right? So you try to understand the concept. Okay, now next is if the sum of the gain of all the winner is equal to the sum of losses by all the loser. That means sum of the game of A is equal to sum of the game of B. If it is equal, then it is called a zero sum game. Keep in mind, MCQ. What do we mean zero sum game? The sum of gain of player A is equal to sum of loss of player B is called a zero sum game. On the other hand, if the sum is not zero, if the sum is not zero, then the sum of all gain is not equal to zero of all losses, then it is called a non-zero sum game. It is called non-zero sum game. Is it clear? What is sum zero sum game and non-zero sum game? Right? We see how to work out it. Don't worry. Thus, a game with a two player where the gain of one player is lost to the other is known as a two-person sum or rectangular game. A two-person game having two strategy or each player is called a two-person 2 by 2 game. Similarly, the game of a two strategy for one player and more than two strategy for n strategy for the other is a two-person 2 by n games and so on. If there are two-person 2 by n games, such are two strategies for the player A. If the 2 by n, the n strategy for player B. Pure strategy game. See, in pure strategy game, the players say with one strategy throughout the game. In a pure strategy game, the players stay, stay with one strategy throughout the game, right? Now here, in a pure strategy game, these are some steps. To write down the payoff matrix with the maximizing the player, right? Payoff matrix is already given, and from that we have to find out the minimum and the maximum one. Row minimum we have to find out, column minimum we have to find out. Last time I have explained with the help of case, right? Similarly, here column wise we have to find out the column maximum. From each column we have to find out the column maximum, and from that we have to find out the minimum. If there are two arrow elements, that is, if it is maximum is equal to minimax, then it is called a saddle point. What about saddle point? Saddle point means the whatever the max min and min max we selected from row and column, if it is equal, then it is called as a saddle point. And if it is not equal, if there is a saddle point, then it is called as a pure strategy. If there is no saddle point, then it is called as a mixed strategy game. Keep in mind, right? If there is a saddle point, it is called a pure strategy game. If there is no saddle point, then it is called a mixed strategy game. The strategy corresponding to the saddle point, right, of either row or column, is called an optimal strategy for the two players. While the saddle point is the value of the game. Whatever the value of saddle point, it is called the value of the game. If there are more than one saddle point, situation may be like this. If there are more than one saddle points, then the solution, there are multiple solutions. There are multiple solutions for each saddle point. If the errored element, or that means if max min and min max are not same, if max min and min max are not same, if max min and minimum are same, it is called saddle point. But if max min and min max are not same, then there is no saddle point, and in this case, it is called as a mixed strategy game. It is called a mixed strategy game. It means that the optimal strategy may be in between these two values. Right? Note down one example. Come on fast with, let there be two firms, A with 2 strategy and B with 3 strategy. Note down this example. Come on, do fast. I will give you 5 minutes. Note down the example. We'll find out the solution so that the above theory component you will understand very easily. Yes? Are you noting the example? Come on. Have you taken pen pencil?
Yes,
Come
sir.
on, keep on interacting. Is it over? Shall I proceed?
Yes,
Solution?
sir.
Good. Solution. I will try to explain the example, right? Uh, let there be two firms. How many firms are there? A and B firms. There is a competition between these two firms. The first firm, A firm with a two strategy. How many strategies are having with firm A? There are two strategies. B firm, opponent to A, there are three strategies. Their strategies and corresponding payoff are as given below. Right? As I said, the firm A and firm B. The firm A, there are two strategies. Firm B, B2 and B3, there are three strategies. Right? And this is the payoff matrix. This is the payoff matrix, which is decided by using the past historical data. The problem is created, but the Newman, he studied how to create the problem. We are getting a ready-made problem. We are not going to develop in the problem, but the Newman, father of game, he has created his problem. He started working how to create the problem, and once the problem is created, then we have to solve. That means problem creation and then solving. But here in our case, we are not going to create the problem. The problem is not ready, but only how to solve and apply the actual application. Okay, so three strategy and two strategy. I will copy this. Come on, do fast. Under solution, you copy this. Firm A is this, and this is firm B. Same values I copied. firm B. As I said, the firm B is a minimizing player. Both cannot minimize, right? Here, the one is minimizing, another one is maximizing, because we have to apply the strategy and find out the optimal one, right? Minimizing. Concept is different, right? Here, player is minimizing player, and the firm A is maximizing, right? Firm is maximizing, right? Firm is maximizing.
Yes, sir.
Now here we have to find out the, what is to be find out now? We have to find out here a minimum from the row, right? So here minimum, we have to find out the minimum, right? We have to find out the minimum from the row, right? So I can write here for understanding row minimum, for understanding row minimum. And here we have to find out the maximum from the column. Maximum from the column. Why? Because it is player A is maximizing, right? And now here maximize from column. Okay. Now we'll work out row wise. All of you, are you with me?
Yes, sir.
Yes.
Yes, sir.
Okay, now we have to find out minimum from row. So from row, which is the minimum one?
2.
2 is the minimum one. From second row, which is the maximum one? Sorry, which is the minimum one?
6.
6.
6 is the minimum. Similarly, from column, which is the minimum one? Sorry, no, find out maximum. Which is the maximum one?
7.
7.
7. From second column, what is the maximum one?
10.
From third column, what is the maximum?
6.
Is it clear? Now, if you try to read the theory, very easily you will understand. Because the same thing I put in the theory component, steps. Now the next step is, we have to select the maximum from minimum and minimum from maximum. Are you getting or not? So that is why the name is max min and minimax, right? We have to select the maximum from minimum, right? Maximum from minimum and minimum from maximum. Come on. We have to select the maximum from minimum. Come on. Right? Which is the maximum from this minimum value?
6.
These are the minimum values just now we got, right? 6 and 2, these are the minimum values just now we got. Which is the maximum? 6 is the maximum. 6 is the maximum, right? Okay, I made this arrow, and what I write now, what is my strategy? What is my policy? What policy I adopted? Max min policy I adopted. Are you getting or not?
Yes, sir.
Which policy I adopted? Max min policy I adopted. Similarly, we have to select here. Now here we have to find out the minimum from maximum. Are you getting or not? We have to find out the minimum from maximum, right? Now arrow. I think you understand. I'll not waste the time in arrow. Okay, it is there. Okay. Right? Now, what is this strategy? What is the name of this strategy? Minimum,
Minimax.
Minimax.
minimax. Exactly. Minimax is the strategy. Right? Now, shall I write here steps? If you require, I'll write down your step. Step number one. Step number one. Yes, sir. In the given table, A is, what is A is? Maximizing player, and B is minimizing player. Step 2, right? Select what is minimum of first row, that is A1 is 2 and A2 is 6. Find what is maximum of column, right? What is B1 is 7, B2 is 10,
Okay.
B3 is,
6.
right? Now step number 3, we have to select. What is to select now? Whether max min is the max min and min max is same, right? Whether max min is equal to min max. Am I right? This max min is equal to max. Yes. Are you getting or not? Are you getting or not?
Yes, sir. Clear,
Yes.
sir.
What is the meaning of this now here? Okay, the 6 means this element. I will change the color of this element, and this is called a saddle point, right? This is called a saddle point. I'll change the color of this element. I'll make it dark one, green. I'll make it. Okay. Okay, this is called the saddle point. You understand what is my saddle point now? Practically. Hmm? This is the saddle point. Now, because both 6 are same, both 6 are same, therefore this is the saddle point. If it is not same, then there is no saddle point. So it is called a mixed strategy game, right? Mixed strategy game. Now here the meaning of this is, now it is to be clear that, what is the conclusion? See, it is to be clear that the firm A is adopting the optimal strategy A2. Getting my statement? Firm
Yes, sir.
A is adopting optimal strategy A2. A1 is not going to be adopted by the firm A. Similarly, the firm B is adopting a B3 strategy. Are you getting?
Yes,
The
sir.
opponent party, firm B is adopting the optimal strategy B3, so that he can think that my loss is minimized. If firm A decide A2 is an optimal strategy, then firm A think that or assume that my gain is maximum. Now, what about A1 and A1? A1 is not at all adopted, so it is 0. B1, no strategy is adopted. A1. In case of B player, B firm, the B1 and B2, these are the two strategies are not going to be adopted, right? The B1 and B2, no strategy is adopted. Now here, the strategies to be adopted, step number 4, just in short I will write, right? Not in lengthy. Step number 4, same thing I would write. Step number 4, the firm A is adopting which A2 strategy. Therefore, so therefore, it is represented as A flare, right? The first strategy that is 0, but the second strategy is adopting that is 1. That is why I put 1. You are understanding? Are you understanding? Firm A is adopting A2 strategy, right? That is second strategy. So first strategy I am not adopting. That is why what I put? I put 0. Similarly, in short I am writing it. Similarly, B firm is adopting which strategy adopting? Come on,
B3.
right? Therefore, it is represented. It is
Represented.
Tell me now, how it will represent? B, how it will represent?
0.
0. Come on. Again 0.
Then
Am I
1.
right? Then 1. Why 2 times 0? Because how many strategies are there? 3 strategies, and out of these 3 strategies, only one strategy is finalized. Therefore, the strategy, whichever is not selected, should be 0. Right? Then 1. Are you getting or not?
Yes,
Right?
sir.
Now, the conclusion is thus a optimal strategy are pure. Am I right? Is it pure or not? Yes, it is pure.
Yes, sir.
When we can say pure? Remember definitions. When we can say pure? Because the sum is equal. If 6 is equal to 6, then it is called pure strategy, right? The strategies are pure, and the optimal value of the game, is given by saddle point, and that is how much? Come on. Come on.
6.
6. Right? That is why the optimal value of the game is given by the saddle point 6. Hence, the A will gain maximum 6 units per play, and B will lose minimum, not maximum, right? Minimum 6 units per player, right? What is the meaning of this?
Yes, sir.
What is the meaning of this? How I can write it? Per player. The meaning of this is, right? It means B makes payment A in this game. Also, the value of game is non-zero, right? Non-zero. It means is it is if it is 0, right? If 0 0, A is 0, B is 0, then it is a unfair game, right? fair game. But now it is non-zero. It means that it is unfair game. Right? Or here I written the conclusion in my word. You can write in your word also. The final interpretation that depends on the depend upon the user. But the process you should try to understand is maximizing player. Select. Okay. Now if you try to read out this pure strategy algorithm, clear cut you will understand that the concept of the game. Now next game is next type is all of you with is it over? Have you noted?
Yes, sir.
Also the random game is non-zero unfair. Okay, now I'll finish the next concept also. Very simple. Mixed strategy game. It is opposite to the pure strategy. See, try to understand. When for a game, given a game, we do not get a saddle point. Right? Again, once again, I'm reminding you. Keep in mind. If there is a saddle point, it is a pure strategy game. If there is no saddle point, it is a mixed strategy game. MCQ type questions. What is mix man, max min, what is min max, right? You should have to clearly understand this. That means that max min not equal to min max. I'll show you max min not equal to min max. So this is max min is 6, min max is 6. If 6 is not equal to 6, it means there is no saddle point. It is a mixed strategy game. It is a mixed strategy game, right? In It is a case of a big strategy game. Yes. Here the player makes the different strategy. Now here player they are going to mixing the different strategies. Right? The A1, A2, right? Player B1, B2, right? Or multiple strategy they are going to mixing the strategy of all strategy are going to be mixed here. Right? Now how it will work out? We use the algebraic method to find out the solution of 2 by 2 game with mixed strategy without saddle point. Right? Without saddle point. Consider the payoff matrix this. Player A, this is the player A. Try to understand this algebraic notations. If you understand this, the thing is in the problem. Right? Are you with me?
Yes, sir.
Yes, sir.
Yes.
Okay. The firm A has got a two strategy. The same example it is. Firm A, A1, A2, these are the two strategies. Firm B, these are the two. Again, for firm B, there are two strategies only. A also two strategy, B also two strategy. In earlier case, the A were having two strategy and B were having three strategies. Now, in this case, both are equal strategies, right? Now, see if you look at in the bracket, I have written P and 1 minus P. What is that P? I described below. But I'll explain. This is because the pure strategy, mixed strategy is based on the probabilities, right? The probability means estimation, and that is why the mixed strategy is always keep on guessing the opponent, right? Without guessing, it is not possible, right? Because it has used the probability distribution. Okay, I'll explain now. The A1 strategy probability is P, the A2 strategy probability is 1 minus P. Similarly for for B, B1 is equal to Q, for B1 Q probability and for B2 1 minus Q probability, right? That means whatever probability is assigned to B1, the rest of the probability is assigned to B2. The meaning is like this. Why? Because the summation of the probability is always 1, right? The summation of the probability is always 1. Therefore, here the rest of the probability, that means the 1 minus whatever the probability. 1 minus means whatever we are going to minus probability, it is definitely either 1 or 0. Lies between 1 and 0. Lies between 1 and 0. So that is why here 1 minus Q. Now the P means probability that A, concept of this, try to understand. P means the probability that A uses the strategy A1. The probability of P, that means the A uses the strategy A1. We don't know, the probability is estimation, right? It is a prediction. Andaz, right? 1 minus p, probability that A uses strategy 2. 1 minus p means when A2 is used. Similarly, the Q means the probability that B uses strategy B1, and 1 minus Q means probability that B uses strategy B2. Right? Until and unless we have a value, we cannot be able to predict it. Right? So we should know the probability, otherwise it cannot be calculated. How it is to be calculated? The next step is given for player. Is it understand this? The bifurcation? Very simple, right? The which strategy, what probability is given. That is the description I have given here. Step 2 for player A. Step 2 for a player A, right? For player A, P and 1 minus P should be such that he should have a same payoff irrespective of B using B1 and B2. Means expected payoff, algebraic, right? Expected payoff to A when B uses B1 is equal to expected payoff to A when B uses B1. When B uses B1, what will be the expected payoff of A? Is equal to expected payoff of A when B uses B2, right? When B uses B2. That means when B is using B1, what is the expected payoff of A? When B is using B2, then what is the expected payoff? When B is using B1, that means B is using Q probability. When B is using B2 means 1 minus Q probability. Say for example, if a B is using a A1 strategy, so A11 multiplied by Q, right? And we have to addition of this, then whatever result we are getting, that is an optimal strategy. Okay, we'll work out. So expected payoff of A when B uses B1 is equal to expected payoff to A when B uses B2. That is the same statement in a algebraic equation I have noted here. A11 multiplied by P. What is A11? A11 multiplied by P. A11 multiplied by P. What is this P? Probability of a strategy A1 to be used. So A11 multiplied by P, right? Plus A21 multiplied by 1 minus P. A21. That is this A21 multiplied by probability of 1 minus P. It means that when B is using B1 strategy, then what is the payoff of A is calculated by using the A11 multiplied by P plus A21 multiplied by 1 minus P. Similarly here, A12 multiplied by P plus A22 multiplied by 1 minus P. A22 multiplied by 1 minus P, and this is what the expected payoff of A is worked out. Very simple, right? Simply multiplication. Therefore, the solving we get this equation P is equal to, or B also, A22 minus A21 divided P is equal to A. By applying the mathematical rules here, we are getting P is equal to A22 minus A21 divided by A11 plus A22 minus A21 minus A12, right? The P is separated, right? P is separated here. The probability, and then we can find 1 minus P. Hence, the optimal strategy for A is P and 1 minus P. What is the optimal strategy of A? P and 1 minus P. And P is calculated here. If you calculate the P by using this equation, it means directly we have to subtract from 1 value of P, we will get the 1 minus P. Both values we received here. Same techniques we have to apply for the B. We must use the expected payoff of B. Now, expected payoff of B we have to work out. In this case, A11 multiplied by Q of A11 multiplied by Q, right? Because expected payoff of B we have to work out. Just reverse. right? Plus A12 plus A12 multiplied by 1 minus Q, 1 minus Q is equal to, right, A21 multiplied by Q plus A22 multiplied by 1 minus Q. C, right, is equal to A21 multiplied by Q plus A22 multiplied by 1 minus Q. Therefore, again the Q is worked out by using the similar method, right? Now, once we get a Q, that is again the probability of B. Q means the notation I changed. Again, it is the probability of B, right? When expected payoff of B is calculated. Now here we can get 1 minus Q. So whatever value of Q we have to subtract from 1. So we'll get here. So Q and 1 minus Q. These are the optimal strategy for B. Similarly, here the optimal strategy for A is P and 1 minus P. If you get these values, then just we have to decide depending upon the value which is an optimal game of value, right? Now the value of the gain for A is, how to work out? Value of gain is calculated by using V. V is equal to expected payoff to A when B which is B1 multiplied by probability that B which is B1. Same above equation. Simply we have to put here plus expected payoff of A when B which is B2 and probability that B which is B2. Right? So the same equation here we use to calculate the V, and putting the values of P and Q and solving we get the value of V, the final value we are getting, and this will be the value of a gain. This will be the value of gain. Right? So if you find this little bit difficult or confusions, then there is one more method that is called the direct method to find the denominator by considering the diagonal elements of a payoff matrix. Right? Now here, diagonal, what do you mean by diagonal elements? Are you with me? We'll work out example,
Yes,
don't
sir.
worry. Right? If you practice one example, you'll understand. What do you mean by diagonal elements? Non-mathematics students may be there and they might find this somewhat little bit difficult, not much, little bit difficult. Okay, what are diagonal elements? Come on. You are a mixed strata, some students from science, some students from engineering, so you should know the diagonal elements. What about diagonal elements? I'll show you here. The diagonal elements means the order of row and column is equal to 1. So this is A11 is a diagonal element and A22 is a diagonal element. Right? That means the R is equal to C is called a position. R row position is equal to column position is equal to row position is equal to column position, then it is called a diagonal element. So this is the diagonal element A11, right, and A22, right? Am I right? Now say A11 plus A22 minus A21 minus A12. Just very simple. A11, A22, A21, A1. Finish. Cross elements are taken. A11 plus A22 minus A21 minus A12. Finish. By using this, we have worked out the denominator. D, that is denominator. Now probability of using first row A1 is, right? So P is equal to second row difference starting with A22. P is equal to second row difference starting with A22. So second row difference starting with A22. That is this, right? Here. Now probability of using row A1 is this A22 minus A21 is divided by D, and similarly here A22 minus A12 divided by D. Similarly, the first column B1 probability, right, is worked out the second column difference, that is A22 minus A12 divided by D, and the value of the gain for A is V, the difference of a cross product of diagonal element divided by D. So difference of cross product A11 multiplied by A22 minus A21 multiplied by A12 divided by D. Divided by D is called a V. Finish. It's a direct method. right? Direct, by using a direct method, only we are taking a diagonal elements. So little bit confusion is there as compared to the previous method, because there is no much algebraic equations are available in direct method, right? But from exam point of view, right? From exam point of view, you should have to know the formulas, how the value of gain is to work out by using a direct method and without direct method. What is P, what is 1 minus P, what is Q, what is Q1, what is strategy, right? What are the different types of games, what are the different types of strategies in the game, right? So these are the concepts which are very important. Now we'll have an example, and then shall I continue? Or we have next important lecture? Shall I continue or we'll stop?
Continue, sir.
Shall we continue, all of you?
Yes, sir.
Yes, sir.
Okay, so we'll finish. Better we'll try to finish as early as possible, because again next week I'm entirely busy. Sure. Note down the example. Note down the example. Player A and player B. Note down this example. Come on, do fast. Note down the example. Who is having next lecture? Students, who is having next lecture?
Sir, Vandana, IB, business economics.
वंदना मॅडम नाही काय चेक करा, मी लेक्चर कंटिन्यू करतो.
काही पाठवलं पाहिजे.
नाही नाही, चला मी पुढं सर घेणार लेक्चर सांग. Okay, chalo. Have you noted the problem? The player.
Yes.
Shall we start the solution? The solution is with me. Just very brief. Slowly, I will explain, and you note down the example or you solve the example. Right? Shall I start?
Yes.
Yes, sir.
This is the example, right? Say player A, player B. Player A has got two different strategies, and player B has got two different strategies. That is strategies B1 and B2. A and A1 and A2. Right? The solution, right? First of all, what is the first step? First of all, we have to check whether there is a saddle point or not. If there is a saddle point, then the example belongs to the pure strategy. Otherwise, it is not a mixed strategy. We are working with mixed strategy. So, always, first step is to check the saddle point. And we already discussed how to check the saddle point. What is the method to check the saddle point? Come on, note down this table fast, very fast. Step 1, note down this table. I will explain meanwhile. Okay, say from this table, first of all, we have to find out row minimum and column minimum. What is row minimum? First 3 is the row minimum, right? Second row, what is minimum? 1 is minimum. 1. Right? And from this row minimum, from these two elements, what is the maximum one? So 3 is the maximum. So as per our policy, we decided max min. Are you getting or not? From minimum, we find out maximum. The same policy is there to find out the saddle point in earlier case also. Similarly, from column we have to select the maximum one. From column 4 is maximum, so I put here 4. From second column 5 is maximum, this is the 5. Now the maximum is 4 and 5, and out of this maximum 4 and 5 we have to select the minimum one, that is minimax policy is applied. Minimax policy is applied. So what is the minimum? 4 is the minimum. So this is the 4 is the minimum and this is 3 is the minimum. Right? This is the 3 is the minimum. Now here we have to test, is it max min is not equal to minimax, or is it max min is equal to minimax? Is it equal?
No, sir.
No, it is not equal. Are you getting out? Because max min is 3. Yes, fine. This is 3. Max min is 3. Is it equal to minimax? 4? No, it is not equal to. Right? It means that therefore there is no saddle point. No doubt. It means that there is no saddle point. Right? It means that there is no saddle point. There is no saddle point. Hence, if there is no saddle point, it means the hence there is no mixed, sorry, there is no pure strategy. Hence there is a mixed strategy to be applied. Right? Hence there should be a mixed strategy to be applied. Do you understand how to decide whether it is pure
Yes.
strategy or mixed strategy? It's clear, very simple. Now we go for next step, that is step number 2, find the probability. Right? Come on, copy the tables. Same. Copy the table. Same. Player A and player B. A1, A2 strategy, B1, B2 strategy. Same values, that is P of matrix 3, 4, 5, 1. B1 is Q probability, B2 is Q minus 1 probability, 1 minus Q probability. A1 means P probability, A2 means 1 minus P probability. Right? Now,
Done, sir.
good. Chalo, next. Next. Now here, as we noted in the steps in the algorithm, P is equal to probability that A uses A1. Note down. P is equal to, what is P? Small p, yeah? P is small. Equal to probability that A uses A1 strategy. 1 minus P is equal to probability that A uses A2 strategy. Similarly, K is equal to probability that B uses B1 strategy. Similarly, B uses B2 strategy, that is 1 minus Q is equal to B uses B2 strategy. We have defined here, we have described. Come on, note down this after this, right? That means here clearly we describe that who is using which strategy, what probability is using which strategy. That's what. The probability. Which probability is using for which strategy of which player. That we here describe. Because the same thing we are using in notation. Same thing we are using in notations. Yes. Over. I have a solution, just I'm going to be explaining. I'm not going to writing again, rewriting. It will take more time. Okay, chalo. Shall I move to the next part? Step to understand?
Yes, sir.
Yes, chalo, next. Okay. If you want some more time to note down the example, tell me. I will give you the more time, you don't worry. But systematic, you note down this. Note down, instead of noting down, you try to understand and you to try to solve on your own. Step 3. Now the step 3 is to find the P and Q. Say in step 3 we have to find the P and Q. Very important. Right? Use the diagonal elements to get. Now here which method I am applying? I am applying direct method. Doesn't matter in which method you are applying, right? But we use the direct method because the complications of calculations will be calculate direct method I am using. Direct method. Using direct method. Like this, using direct method. Okay, use the diagonal elements to get. Come on, I will explain now diagonal elements. As I said, diagonal elements means the first row, first column, A11 and A22, these are the diagonal elements. Hello? हाँ बोलो. हाँ बोला 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 बोला.
सर त्या मॅडम येणार होते ते प्रोग्रामच कॅन्सल केला विशेष
Okay, sure. Huh. Diagonal elements, right? So A11, A22. This is the diagonal element. This diagonal element and this diagonal element. Cross element. I think you understand. Instead of the matrix definition, it is a part of matrix diagonal element. 3 and 1. These are the first diagonal elements. 3 plus 1. Very simple. 3 plus 1 minus what is 4 minus 5. 4 minus 5. Right? Now 3 plus 1, 4. Plus 4 and minus 4 has gone. How much is remaining? D is minus 5. At least you understand this calculation. Come on. Come on, students. You understand this calculation?
Yes, sir.
Yes, sir.
Okay, therefore P is equal to, right? Therefore P is equal to, how it is work out? P is equal to second row difference starting with A to 2 is equal to 1. P is equal to second row difference. P is equal to second row difference, right? Say the second row difference means this difference. The difference of this, right? Difference we have to take, right? Difference we have to take. So the second row difference is 1 minus 4 divided by minus 5, right? A to 2 is equal to 1, right? Now minus 3 divided by minus 5. The symbol will go out, am I right? Mathematics rules, right? 3 divided by 5. Similarly, the Q is equal to second column difference. Second column difference, right? This is second column difference, second row difference, second column difference, 1 minus 5, right? So 1 minus 5 divided by minus 5. So minus 4 divided by minus 5 is 4 by 5, right? Therefore 1 minus P, value of P is 3 by 5. So 1 minus 3 by 5. 1 minus 3 by 5. Note down properly and work out on calculator. Put into the fraction result. So therefore, 1 minus P is equal to P is calculated here. P is 3 by 5. So P is 3 by 5. So here the P is equal to 1 minus P, 1 minus 3 by 5. Right? So 1 minus 3 by 5. Come on.
5 minus 5. 3 minus 5.
How much? This is something. This is 1 minus 1 minus 3 by 5. Right? Here. This is 1 minus 3 by 5. This is 1 minus 3. Come on, next. Work out. How much? First you work out 3 by 5 and then you subtract. How much? Tell me now. I think some different value may come. One minus 3 by 5 is equal to how much? Is it correct? 2 by 5. Right? Okay. So similarly, 1 minus q. 1 minus q. Q is calculated here. Q is 4 by 5. Right? The q is equal to, so 1 minus q, 1 minus 4 by 5. Right? Again, this is wrong. This should be 1. 1 minus 4 by 5 is, yes, right, it is 1 by 5. Right? It is 1 by 5. Now the maximum gain for A will be given by the value of the gain. Have you understand this calculation? Direct method I am using. Diagonal elements simply we are using to work out the P and Q. Right? So you look at the table, put the values, you will understand. Now the maximum gain for A will be given by the value of the gain. Okay, come on, I will give you the time. Do fast. Once it is over, just remind me. Over?
Yes, sir.
Okay, chalo. Now the value of gain we have to work out, and the value of gain is equal to, keep in mind this formula, the difference of cross product of diagonal elements divided by D. Difference of cross product of diagonal elements. The cross product of diagonal elements, right? The difference of cross product of diagonal elements, the diagonal elements 3 multiplied by 1 minus 5 multiplied by 4, right? Difference of cross. Say 3 multiplied by 1 minus 4 multiplied by 5 divided by D. D just now we have worked out here 1 by 5, right? So now here 3 minus 20 divided by minus 5. So minus 17 divided by minus 5. So 17 divided by minus 5. Very simple mathematical rules we have to apply. Now, come on. This is the final value we calculated, right? Final values we calculated. Are you with me?
Yes, sir.
Okay, now here the calculation of this P and Q is important, and how we calculate it by using a diagonal elements. Right, the first of all here the D is calculated by using diagonal elements. Just I repeat. After calculating the D, we calculated the P again by using this formula. The second row difference starting with A22 is equal to 1 divided by D, right? Okay. Similarly, Q is calculated, right? And once P and Q is calculated, simply we have to subtract from 1. Here we subtracted the whatever P is calculated, we get 2.5. Similarly, Q is calculated 1 minus Q. Q is 1 minus Q is calculated, right? So Q is already calculated. So 1 minus Q, that is 1 minus 4.5, that is 0.1 divided by 5. The maximum gain for A will be given by the value of the gain. Now, actual value of gain is calculated, and the actual value of gain formula is, because all this we need for calculation of D and probability. Now 3 multiplied by 1 minus 4 multiplied by 5. So diagonal elements, product, right? 3 multiplied by 1, this 3 multiplied by 1 minus 4 multiplied by 5, right? This and divided by D. So here same thing we worked out. V is equal to 3 multiplied by 1 minus 4 multiplied by 5 divided by D. So 3 minus 20 multiplied by minus 5. So minus 70 multiplied by minus 5 minus is about 17 divided by 5. Hence the optimal strategy for player A is. Hence the optimal strategy for player A is P comma 1 minus P. Now look, I will explain this. Hence the optimal strategy for a player A is P comma 1 minus P. For A, what is P? For A, what is P? For A, what is the P value calculated? 3 by 5, right? For A, this is the 3 by 5, right? And what is 1 minus P? What is 1 minus P? 2 by 5. 2 by 5. So here the probability of the player A, in order to find out the optimal strategy, is 3 by 5 and 2 by 5. So 3 by 5 is the P value of P. 1 minus P is the probability of 1 minus P. That is 3 by 5 and 2 by 5 is 0.6 and 0.4. Or it is also converted into the percentage, that is 60 and 40%. Right? 60 and 40%. It means that the probability of there is a 60% probability to select the strategy A1, and there is a 40% of probability to select the strategy of A2. Are you getting or not? Meaning of this, right? Meaning of this is, that means there is a probability of, that is optimal strategy will be decided depending upon this percentage, because 60% probability, 60% is saying that we can select the A1 strategy, and 40% are saying that select the A2 strategy. Similarly, for the optimal strategy for player B is Q and 1 minus Q. So the value of Q is, where is the value of Q? Q is 4 by 5 and 1 minus Q is 1 by 5. So here the Q is 4 by 5 and 1 minus Q is 1 by 5, which is already calculated. It means that here 0.8 and 0.2 means this is how much? 80. Huh? This is 80. Now the meaning of this is, right? In case of player B, the meaning of this is 80% probability says that you can select the B1 strategy for player B, and 20% probability says that you can select the D2 strategy. Are you getting or not? Are you with me?
Yes, sir.
Yes, sir.
Right. Okay. So thus A should, right? Thus A should mix the strategy so as, right? Mix the strategy so as to use the strategy A1 is equal to 60 and A2 is equal to 40. Thus, A should mix the strategy so as to use the strategy A1 is equal to 60% and A2 is equal to 40%. Why mixing? Because right? In case of A1, 60 and 40 is better, right? This would result in an average gain of a maximum. This would result in average gain of maximum, that is 75 minutes per day to A. Similarly, the mixed strategy of B of using B1 is 80% and B2 is 20%. It would be result in a minimum loss of 70.5 minutes per day. So if you are adopting the strategy of mix, that is 60%, go for A1 strategy and 40% we are considering A2 strategy. Similarly, in case of B player is 80% he is depend upon the B1 strategy and only 20% he depend upon the B2 strategy. Are you getting or not? In earlier case, either A1 or A2. But now here it is not like that. We are using. Both we are using because it is called a mixed strategy game. Right? So once again I conclude this. This would result in an average gain of maximum 17.58 because this we already calculated here. Value of gain is 75 units, right? It is an units per day to A, but it's depend upon the mixed strategy because in case of A, 60% A1 strategy is used, 40% A2 is used. In case of B, 80% B1 is used and 20% B2 is used. By mixing these all strategies, it would result in minimizing the loss of 75 units per play. Therefore, the final decision is that the B will make a payment to A in this game, right? Therefore, B will make a payment in this game. So this is called a mixed strategy game, right? Now, here the important is, the concept wise important is, right, how to work out the value of gain. V, this formula is expected. What do you mean by P? Probability, in case if suppose the table is given, then they will ask how it is to work out the P and Q, the calculation of P and Q by using both the methods, right? The concept wise, if you solve this example, you will understand the whatever theory we discuss under the mixed strategy game, right? I think this example is already discussed. Okay. Now, the next component of an game theory is principles of dominance. Shall I explain principles of dominance?
Yes, sir.
Okay, I will explain the concept and examples and we will try to finish today only the game theory, right? Because only simple part is remain, only this much part will remain. The principles of dominance is one of the concept which is included in the syllabus, right? What is that concept you try to understand, because most probably the questions will be based on this. As I said at the beginning, whenever we say the question paper of university, right? I have a vast experience of working on examination, right? So always we give the instructions to the examiner that the paper should be set on entire syllabus and weightage should be given equal to all the units. Keep in mind, weightage should be given equal to all the units. So 100% there will be a questions from each and every units, right? There will be a questions from each and every units. While setting the questions, there are three types of questions to be set by the examiner. The first is the easy level, difficulty level, right? Easy difficulty level. Then the second type of questions, they set the moderate, neither too difficult or too easy. It should be a moderate. And third type of level is at a difficult level. Again, there is no equal weightage is given for the easy, moderate and difficult level. Difficult level questions, hardly 20% weightage is given for the difficulty level questions, right? And more than 50% weightage is given to the moderate level and the remaining weightage, right, that is whatever 30, 35, 30, 40 is given to the easy questions. So questions not too difficult or too easy. Well, getting or no? This is what the logic behind the setting of question papers of the university, right? Now, while setting the questions, you need to write the questions to be set. And this is the mathematical paper, so I think there will be a 30 questions. Am I right? There will be a 30 questions, right? Each questions
Yes,
carry 2 marks. Each question carry 2 marks. For other papers, I think, some students they might be not aware about this. For other theoretical paper, theoretical concept or theory papers, there will be a 60 questions. The same logic, same techniques is applied. 3 difficulty levels. The questions will be based on all entire units, and the equal weightage will be given. The weightage of marks is already given in the syllabus. Accordingly, the percentage of setting the questions will be decided. Because some units they have a 20% mark, 20 marks, some units they have 10% marks. So 20%, 20 marks and 10 marks. In the proportion of 20 and 10 marks, the questions will be set. Not equal weightage. Again, the whatever weightage is allocated in the syllabus. In the syllabus, CBS system, when the CBS system came into the existence, it is a uniform pattern. And uniformity is not only in India, uniformity is for all entire examination, not only in India, uniformity throughout the nation, throughout the world. Because now it has a centralized system, CBS, right? So choice-based credit system is called choice-based system. Okay, now is it clear? For this paper, 30 marks. 30 questions, each questions carry 2 marks. For other theory papers, there is 60 questions. Again, each carry 1 mark, and out of 60, how many correct answers, only that will be counted. Right? Okay. Now, have you given the mock? I think examination get declared very soon, huh? Because they are at the end of the preparations. Yesterday only we had a meeting with Vice Chancellor, right? So now this time they have made a lot of changes. Everything is automation. From the day when from the day one, the automated grades are going to be generated. And now onwards, everything you will get online. Transcript you will get online. Mark sheet you will get online. But that means from your dashboard you will get it. No need to go to college or no need to go to some university to apply the transcript and to get the transcript. Everything is automation. Very nice system they have. Okay, so I will explain this concept. And maybe within 2 days, I will share you the MCQ team, right? You can notes, problems for the preparations. Whatever questions I am sharing to you, don't assume that the questions from the list of questions or the question banks. No, it is not like. It is not like that. Because already the question bank is very big bang. Subject wise, right? And randomly the questions are going to be picked up. As I said, we have given in the system difficulty level 1, 2, 3 coding. So how much percentage? 20% easy level. So only 20%, one difficulty level questions will be fetched by the system. The system generated. Nothing is in the hand of university. Sure. Over the other strategy, right? Sometimes it happens in the play. So in such case, this principle can be applied to m by n size problem. Right? In case of pure strategy problem, it solution and a mixed strategy problem, it can help to reduce the problem of 2 by 2. Right? So where it is applied into m 2 by 2 size, which can be solved further using the algebraic methods. Again, the equations are reduced up to 2 by n or maybe m by 2 also. Persons versus 2 persons. Another, using the graphical methods and linear programming methods, but this is out of your scope. Right? Graphical method and linear programming method is not at all included in the syllabus because the game theory is very interesting and very powerful technique which is used in industry, right, for taking the decisions in a different strategy, different conditions. Step 1, to check if there is a saddle point. Again, the same thing. How to check? The same technique. If a saddle point is there, the optimal solution is directly obtained. Yes, we already seen that. If the problem does not have a saddle point, then reduce it to 2 by 2 size by using the following rule of dominance. There are some rules, some certain rules are there. Practical, with example, in the problem will clear that. Right? If it is a problem of m by n or m by 2 or 2 by n, then it should be reduced 2 by 2 by using the dominance rule. The first rule of dominance, there are 3 rules of dominance. First rule, if all the elements in a row, say ith row, are less than or equal to corresponding elements of any other row, say ith row, right? Or ith row, then neglect the ith row. If all the elements in a column, say rth column, are greater than or equal to the corresponding element, then any other column, say sth column, then neglect the rth column. Right? We are ignoring. A pure strategy may be dominated if it is inferior to the combination of two other strategies in a certain fixed proportion. That is k and k minus k, 1 minus k. So these are the dominance rules. Will apply on problem, you'll understand. Right? It's not explaining rotations. On getting the reduced pure matrix of size 2 by 2, we solve the further using the algebraic method to get the optimal solutions. Again, we have to use an algebraic method to find out the optimal solutions. Example of this game, note down, come on, fast. Solve the following game, the B and A1. There are A player, B player, A1, A2, A3, B1, B2, B3 strategy. There are more than 2. There are more than 2 strategies are there. Right? There are more than 2 strategies are there. Note down the problem. Come on, very fast. With the help of problem, only you understand the dominance rule. It's very simple. Note down the problem. Come on, fast.
Done, sir.
Okay, chalo. We'll have a solution.
Yes,
Find
sir.
out the max min and max min and minimax as follows to check the saddle point. You know how to check the saddle point. Same example you carry on. We have to select the minimum one from the first row. What is minimum? 1. Select the minimum from second row. What is minimum? 2. Select the minimum from third row. What is minimum? 1. Are you getting or not? These are the minimum which was the row minimum we have selected. From this row minimum, we have to select the maximum. From row minimum, we have to select the maximum. So that is called max min principle. That's called max min principle. The 2 is maximum. Am I right? Are you with me? Same thing with this.
Yes, sir.
Now, similarly, we have to find out the column maximum. From first column, what is the maximum? 6. From second column, what is the maximum? 7. From third column, what is the maximum? 7. Am I right? Now, from this maximum, we have to select the minimum. So min max principle we are going to apply it. So from this entire maximum element, we are going to select a minimum is 6, right? Minimum is 6. Is it this 6 min max is equal to 2 max min? Is it equal? No, there is no equal. It means that, come on, it means that there is no saddle point. Are you getting or not? There is no saddle point. It means it is not a make pure strategy, it is a mixed strategy, and dominance rule is applied in mixed strategy only. Right? Now step number 2, as I say, you have to reduce the payoff matrix using principles of dominance. Right? Now we see that, right? Now we see that all the elements of row A3, come on, try to understand, I will explain, the solution is with me, right? We see that all the elements of row A3 are less than and equal to the corresponding element of row A2. That means which row is having a less than element, right? Less element, that is going to be nominated, that is going to be ignored. So we see that all the element of row A3 is this one. Row A3 is this one, right? Look at the example, very simple to understand. We see that all the elements of row A3 are less than and equal to the corresponding element of row A2. Am I right? A3 चे एलिमेंट हे A2 पेक्षा लहान आहेत का नाही? आहेत का नाही? Is it less or not?
Yes, sir.
Now you tell me, is it A3 elements are less than or equal to A1 element?
No.
Is it A3 elements are less than A1 element? आहेत का?
A3 is always less than equal to B and suddenly A2.
All elements. Not less than. It is not less than. Somebody is speaker. Mute the speaker. Okay. You understand not what I'm saying, that all the elements of A3 is less than A2. Am I right? But is it all the elements of A1, A3 is less than A1? No, it is not less than A1. Is it all the elements of A1 is less than A2? No, not less than. Okay, 1 is less than, 2 is less than, but 7 is not less than. But here in this case it is applicable. Are you getting or not? 1 is less than 6, 2 is less than 7, but 7 is not less than 2, so we cannot ignore this. A2, 6, right, is equal to 7. Yes, it is greater than. A2 is not, but here we clear that all the elements of A3 is less than or equal to A2. Hence, the gain to the maximizing player A or the strategy A3 is always less than or equal to the gain on using strategy A2. That means whatever the strategy we are applying and we are getting the gain is always less than, right, of strategy using A2. Hence the strategy A3 is dominated by strategy A2. That is why the A2 is dominating to A3 now. Because whatever solution we are getting A2, right, is always less than A3 now. Because values are less than. That is why always the A2 is dominating to A3. Therefore, the hence strategy A3 is dominated by strategy A2. Then we get A1 and A2. Similarly, look at the column. Is it first column is less than or equal to second column? Is it first column is less than or equal to second column? Very simple. Is it first column? First column is 1 and 6. 1 and 6 is less than 2 and 7. Yes or no?
Yes, sir. Yes, sir.
Yes. Right. Is it first column is less than third column?
Yes,
No.
sir.
1 is less than 7. Fine. But whether 6 is less than 2?
No, sir.
No. So here we clear that the B1 is first column is less than equal to second column, means whatever answer we are getting B2 is definitely less than B1. So B2 is dominating to B1. That is why the B1 is going to be ignored. So in this matrix, the element of column B2 are greater than corresponding elements of column B1. B2 is greater than corresponding column of B1. Thus the minimizing flare passes better. Hold on. Thus, for the minimizing flare B, the strategy B2 is dominated. B2 is dominated to B1. Why? Because always the 2 and 7 is getting the maximum gain. Why? Because here are less values. So by using this cost matrix, payoff matrix, always the profit is getting, B2 is getting maximum than B1. So B1 is going to be ignored. So it's reduced. So now here the B1 and B3, A1 and A2, the problem is reduced. That means in case of reducing the problems, we have to apply the dominance rule, and in case of applying the dominance rule, whether the entire row is less than or equal to any other row, or whether entire column is greater than any other column. So the same column is dominating to the others. Next one. So the matrix, resultant matrix will be this one, because this is to be dominated, right? This is to be dominated. B2 is dominated, right? B2 is dominated by B1 because it is minimizing. So this is dominated. So B1, B3 and A1, A2. B1, B3 and A1, A2. Now here we can reduce the matrix till 2 by 2 using the dominance principle. And once we reduce the matrix to 2 by 2, the same method, direct method, we have to find out. Diagonal elements. 1 plus 2 divided by minus 6 minus 7 is equal to minus 10. Probability, we have to find out the probability, right? 2 minus 6 divided by 10 is equal to minus 4 divided by minus 10 is equal to 2.2 by 5. Therefore, 1 minus p is equal to 1 minus 2 by 5 is equal to 3 by 5. So here the same direct method we are applying. By applying the direct methods, we get the probability of this p is equal to 2 by 5 and q is equal minus p is equal to 3 by 5. Similarly, q is also calculated. The same principles we are applying. Same direct method rule we are applying. 2 minus 7 divided by minus 10, right? That is denominator which we calculated. Minus 5 divided by 10, right? Minus 5 divided by 10 is equal to 1 by 5. Therefore, 1 minus p is equal to 1 minus 1 by 5 is equal to 1 by 5. Fine. Now calculate the value of the gains. Right, 1 multiplied by 2 diagonal elements, 1 multiplied by 2 minus 6 multiplied by 7, right? 2 minus 42 multiplied by 10. So 40 minus 40 multiplied by 10, minus symbol will go out. 40 divided by 10 is equal to 4 is the value of gain. Now here the final result and final conclusion which I am writing here. Thus the optimal strategy for A is, now it is a mixed strategy. So 2 by 5 means 40%, 3 by 5 means 60%, and one more strategy was there, that is 0. We are not going to adopting, right? Because that is dominated. So 40 and 60% probability is used to adopt the strategy A1 and A2, right? Similarly here, optimal strategy for B is 1 by 2. Second strategy is already dominated, that is ignored, and the third one is 1/2. So 50-50%. That means that there is a 50-50% probability to select the strategy of B1 and B3. B2 is already dominated, so B1 is 50% of times, B2 should not be used, and B3 is 50%. So B1 strategy 50% opinion, B2 strategy is not at all applied, and B3 is 50% of times. The value of the game is, right? The value of the game. The value of the game is, what is value of the game? How it is to work out? The value of the game is, what is the value of the game?
4.
This is 4. Value of the game is 4. Just now we have worked out here. Value of game is 4 for A. Thus, A cannot get more than ₹4, and B cannot reduce. And B cannot reduce his loss below ₹4 in this game. Right? Same conclusion. Cannot reduce in this game. So again, who has to pay? The player B has to pay ₹4 to player A. Right? So this is the final conclusion. Right?
Yes, sir.
Just you work out. I will mail you. I will send you this note today only, now only. Right? Both example you work out at home. Very easily you will understand. Right? But you should have patience while solving this example. Right? Any doubts about the game theory? I think many students, they lose their patience, so slowly they drop out. I don't know the reason. Okay, because the subject is not that much easy, and it is not easy to teach online, because the board teaching is required for this particular subject. Okay, fine, right? So you practice this. I will send you the next. I will check syllabus. Whatever is remaining in the syllabus, I will try to cover within 2 to 3 lectures. You don't worry. And if you have any difficulties, we'll have revision sessions also. Chalo, shall I move?
Okay, sir. Yes, sir. Thank you, sir.